Micro rebar changes how concrete reinforcement works, not by adding steel on top, but by mixing it directly into the concrete itself. Each fiber is a twisted strand of steel, around 30 to 35 millimeters long and under 1 millimeter thick. They're added to the mix at a rate of 10 to 18 kilograms per cubic meter. Once inside, they form a dense, three-dimensional network that helps concrete resist cracking and boosts its tensile strength up to 300 megapascals. The twist in each fiber isn't decorative, it's functional. That helical shape creates a mechanical bond with the surrounding concrete, locking each strand in place. That grip helps stop cracks from growing and adds strength long after the concrete has set. Unlike traditional mesh or rebar, this reinforcement spreads out through the entire structure. The result is a slab or wall that performs more consistently and holds up better under stress. It's also easier to work with. There's no rebar to lift or tie, no mesh to position, and fewer joints to worry about. For crews on the ground, that means quicker pours and less setup. In precast plants, it can eliminate entire steps in the process. Helix performs under fire conditions too. The steel fibers stay in place when exposed to high heat, helping the concrete hold together longer. From large-scale industrial floors to tilt-up walls and residential slabs, Helix provides consistent reinforcement throughout the mix. It simplifies the job without cutting corners. Smart Slab reimagines what a concrete ceiling can be by combining structural performance with precision digital fabrication. It spans 78 square meters and is made up of 11 prefabricated segments, each around 7.4 meters long. These segments use a ribbed structure, where the ribs are 30 to 60 centimeters deep, while the shell in between is as thin as 1.5 to 2 centimeters. The entire slab weighs just 15 tons, around 70% lighter than a traditional flat concrete ceiling of similar size. The magic happens in the way it's built. The underside, full of curves and recesses, comes from 3D printed sand molds. These allow for millimeter-accurate detailing that would be nearly impossible with traditional formwork. For the straighter rib sections, laser-cut plywood handles the job. A thin layer of fiber-reinforced concrete is sprayed on first to form the shell. Then, conventional concrete is poured in to complete the ribs above. Once the segments are delivered to the site, they're post-tensioned together. The structure can cantilever out up to 4.5 meters with no extra support. It doesn't just hold up the floor above, it also acts as a finished ceiling below. Services like lighting, sprinklers, and wiring run through the slab, thanks to carefully planned voids and channels built right into the formwork before concrete is poured. DokaXbot Lift doesn't replace workers, it works with them. It's a robotic assistant designed to make high-rise construction faster, safer, and more efficient. Think of it as a mechanical teammate that lifts, shifts, and positions formwork panels on the fly in a crane. No manual hoisting, no downtime between pours. Mounted to the climbing formwork system, DokaXbot travels vertically as the building grows. It handles wall formwork panels weighing up to 150 kilograms, moving them into place with precision. The robot uses onboard sensors and GPS-guided automation to locate exact positions, even compensating for wind or structural movement. It's not guessing, it knows where every panel needs to go. Instead of waiting for the crane to swing into place, crews can call up the robot and continue working without delay. That alone shaves hours off repetitive tasks and keeps the schedule moving. And because the robot works directly from the structure, it stays with the build, climbing floor by floor, just like the formwork it rides on. Safety gets a serious boost too. With DokaXbot doing the heavy lifting, fewer workers are exposed to high-risk zones like slab edges or suspended loads. The robot doesn't get tired, distracted, or injured. It just picks, rotates, and sets the next panel like clockwork. Structures isn't your everyday scaffolding. It's muscle for mega projects. These massive modular lifting and shoring systems are designed to handle the heaviest loads in construction: bridge spans, offshore platforms, precast segments, and steel superstructures. If it's too big for cranes or traditional supports, Structures steps in. At the heart of the system are huge steel trusses and gantries towering frameworks that can span dozens of meters and support thousands of tons. They're fully modular, meaning they can be configured to fit the needs of each project, from launching bridge segments across valleys to lifting entire decks into position with millimeter precision. Each unit is engineered with hydraulic controls that do more than just lift. They push, pull, slide, and align heavy elements into place. Structures systems can adjust in real time, balancing loads, compensating for deflection, and syncing with sensors to track stress across the structure. It's not just brute force, it's controlled, measured strength. One of the system's standout features is the bridge launching gantry. It assembles bridge spans segment by segment, lifting from one pier and sliding the completed section forward as it builds. This method means bridges can be built without heavy ground equipment, even over rivers, roads, or deep terrain where access is limited. The equipment is made for repeat use, with a rugged design that stands up to tough weather, tight timelines, and demanding site conditions. Despite their size, the components break down for transport and reassembly on the next job, flexible enough for infrastructure teams that move from project to project around the world. Sapphire clip-on balconies make adding outdoor space feel more like plugging in than building out. These modular balconies arrives fully assembled balustrades, drainage, flooring, and all ready to attach directly to a building structure without the delays or risks of traditional methods. Each balcony is manufactured off-site in a controlled environment. That means no weather delays, tighter quality control, and quicker timelines. The units are then transported to the site and mechanically fixed to pre-installed brackets on the facade. Once secured, they're instantly functional. No scaffolding, no curing times, no need for edge protection during assembly. The real strength lies in the bracket system. It's engineered to support both vertical loads and lateral forces from wind or occupancy. Balconies can be designed to cantilever or tie back into the structure, depending on the building's frame. The fixings meet structural and fire safety standards, and because everything is tested ahead of time, there's less guesswork on site. Most systems use a hidden slope and discrete outlets to shed water away from the building, protecting the envelope and the unit itself. Balustrades can be glass, steel, or aluminum, with multiple finish options to suit architectural styles. Clip-on balconies aren't just fast, they're consistent. Every unit looks and performs the same, whether it's floor 2 or floor 20. That kind of uniformity helps with planning, budgeting, and even aesthetic approval on large developments. For developers, it means faster builds and earlier occupancy. For installers, it means less risk and less on-site labor. And for residents, it means a private outdoor space that feels solid, safe, and part of the building, not an afterthought. Basetrac doesn't pave, it stabilizes. It's a geogrid reinforcement system laid directly into soil to strengthen weak subgrades before roads, foundations, or embankments go on top. Think of it as giving the ground a skeleton-tough, grid-like structure that spreads loads out, reduces rutting, and keeps everything above it from shifting over time. The grids are made from high-tenacity polyester yarns or fiberglass, coated for UV and chemical resistance. They're strong in tension, but open in structure, allowing aggregate to lock into place through the apertures. This mechanical interlock creates a reinforced layer that acts more like a composite than loose fill. Installation is fast. Basetrac unrolls over the prepared subgrade, followed by a layer of gravel or crushed stone. As the aggregate settles into the grid, it locks in, creating a reinforced platform. There's no curing, no downtime, just compact and keep building. The result is a more stable base with less material, often reducing the required thickness of fill layers by up to 50%. It's used under highways, railways, airport runways, and in embankments and retaining structures. In soft ground conditions like clay, it keeps heavy loads from punching through. In high load areas, it reduces deformation and extends the life of the pavement or structure above. What makes Basetrac so effective is its simplicity. It doesn't require special training or equipment. It just goes in, does its job, and disappears under the next layer. But what it prevents settling, shifting, cracking, makes a major difference in performance and maintenance over time. BLANKE PERMATOP wall is where heating meets design, right on the wall. It's a radiant heating system that integrates directly into vertical surfaces, offering a clean, silent, and invisible way to warm a space from the sides instead of the floor. Instead of ducts or bulky radiators, this system turns walls into active heat sources. The core of the system is a modular panel made from expanded polystyrene with integrated grooves. Flexible PEX pipes snap into those grooves and carry warm water through the wall's surface. Once installed, the panel is covered with plaster or another wall finish, leaving no visible components. Just warmth, radiating evenly. It's designed for low temperature operation, typically between 30 degrees Celsius and 40 degrees Celsius, making it ideal for use with energy-efficient heating systems like heat pumps or solar thermal setups. Despite the low temps, it creates a comfortable radiant effect, heating the room evenly without blowing air or stirring up dust. One of the key advantages is response time. Because the pipes sit just beneath the surface, the system reacts quickly to thermostat changes. It also saves space, freeing up walls from bulky heating units and floors from embedded tubing. Installation is streamlined, panels are lightweight, easy to cut, and can be fixed directly to drywall or masonry. The modular layout allows for custom pipe spacing and routing, which means it can adapt to nearly any wall configuration. Corners, edges, and even sloped ceilings aren't a problem. Some building systems try to hide how they work. EMMEDUE panels do the opposite. They wear their structure proudly. At first glance, it's a sandwich of wire mesh, foam, and concrete. But that combo does more than it looks. It delivers strength, insulation, and speed in one shot, straight from the factory to the job site. The core is an expanded polystyrene panel, usually 60 to 100 millimeters thick. On either side is welded steel mesh, connected by diagonal trusses every few inches. Once on site, the panels are assembled into walls, floors, or roofs and sprayed with 2 layers of concrete. That's where the magic happens. The concrete bonds to the mesh holds to the foam, and the whole thing becomes a rigid, structural element. Despite being lightweight before spraying, the system performs like solid concrete after curing. Walls meet seismic and hurricane-resistant specs in many regions. The insulation core keeps buildings thermally efficient, helping reduce heating and cooling loads. Fire resistance? It's built in. Acoustic performance? Surprisingly high, thanks to the density of the concrete skins and the buffering effect of the foam. Construction moves fast. The panels are prefabricated to size, so there's minimal cutting or trimming. 1 or 2 workers can carry and position each one by hand. After installation, all it takes is a concrete layer and finish coats, and you've got a full wall, ready for paint or cladding. Origami structures don't just fold for fun, they fold with purpose. Inspired by the ancient art of paper folding, these architectural systems take flat, rigid materials and shape them into forms that expand, collapse, and support real-world loads. What starts as a sheet becomes a shelter, a surface, or even a structural core with strength built into every crease. At the heart of these systems is geometry. Each fold adds stiffness, allowing thin materials like aluminum, polymer sheets, or even lightweight composites to act like beams or trusses once deployed. The act of folding transforms flexibility into rigidity. Some setups open like a fan, others pop up like an accordion, but they all use motion to create structure. The big advantage? Portability and speed. These structures are compact in transport and fast to deploy. No cranes, no foundations, no heavy lifting. One moment they're flat-packed, the next they're standing tall, covering space or supporting weight. That makes them ideal for emergency shelters, mobile workspaces, exhibition pavilions, or anywhere quick setup is key. They're not just temporary either. With the right materials and locking mechanisms, origami structures can be semi-permanent or modular, growing with need or folding back when the job is done. Some even integrate solar panels, insulation layers, or acoustic treatments into the folds, proving that form doesn't have to sacrifice function. Designers and engineers use digital modeling to perfect each crease, ensuring that once folded, the system delivers not just shape, but strength. These models account for material thickness, bend tolerance, and connection points so everything folds smoothly and locks precisely. Tunnel boring machines don't roar, they hum with precision. These machines aren't about brute force. They're about turning mountains and cityscapes into passable routes, one carefully carved meter at a time. Whether it's under rivers, through rock, or beneath dense urban streets, TBMs cut paths where people can't. At the front is a rotating cutter, head like a giant circular saw that grinds through soil, rock, or mixed ground. Behind it, the machine carries an entire underground factory. Conveyors remove debris. Hydraulic arms install precast concrete segments to form the tunnel lining as the machine moves forward. It's a continuous operation. Cut, remove, line, and move all in one motion. Sizes vary. Some TBMs carve paths just over a meter wide. Others, like those used for metro or highway tunnels, reach diameters of 10 to 17 meters, big enough to fit multi-lane roads inside. The largest can weigh over 4,000 tons and stretch more than 300 feet long, including support systems. Steering is precise, guided by GPS, lasers, and pressure sensors. It can curve around foundations, dip under rivers, or thread through rock layers, all with millimeter accuracy. The enclosed system means surface disruption stays minimal, making TBMs essential in cities where traditional digging would shut down entire districts. There's also a variety of machine types. Earth pressure balance. TBMs work in soft soils. Slurry shield TBMs handle high water pressure. Hard rock TBMs power through granite. Each is tuned to the job. Ground type, depth, water content, and tunnel size all factor into the selection. What once took years with explosives and hand tools now moves at a steady pace, often dozens of meters per day, with greater safety and less impact. TBMs don't just dig tunnels. They build the future of underground transit, freight, and infrastructure one rotation at a time. Sometimes on a big site, time isn't just money, it's momentum. That's where DokaTruss earns its place. It's not just formwork, it's a smarter way to handle slab pours, especially when every floor looks like the last. Instead of spending hours setting up beams, props, and panels one by one, crews bring in DokaTruss as a complete flying table. These tables are massive, stretching up to 30 meters long and over 6 meters wide, yet manageable enough to move in just 2 parts. Each one is built from a steel and aluminum truss frame, keeping the weight to less than 9.5 pounds per square foot. That's light enough to handle efficiently, but strong enough to hold serious concrete loads. The support legs are spaced far apart, up to 12 feet, which means fewer props, less clutter, and more room to work underneath. Crews can adjust the height on the fly using built-in jacks that offer about 4 feet of travel. When it's time to move, there's no need to take it apart. Just release the pins, drop it onto rollers, and wheel it to the next section. It's built with job site reality in mind. Drop beams, perimeter edges, columns. They all fit into the plan. Hinged wings fold in for transport and open out for full coverage. Safety rails, lifting points, and edge walkways are already part of the system. On repetitive builds like towers or parking decks, that adds up. Fewer crane picks, less setup, and less rework. And because the system links directly with Doka's other shoring gear, it fits right into an existing lineup. You might walk past a building and never notice them, but Harmon curtain walls are what make so many modern structures possible glass towers that look clean, sharp, and seamless from street level to skyline. Behind that look is a system engineered to the millimeter. Curtain walls aren't load-bearing. They hang off the side of the structure like a shell. Harmon designs and fabricates these walls using unitized systems, large pre-assembled panels that arrive on site ready to install. Each panel includes aluminum framing, thermal barriers, glass, and all necessary seals. It's not built floor by floor, it lifted and locked into place, floor after floor, in sequence. The precision is what makes the difference. These panels can span multiple stories, and Harmon systems are built to handle wind pressure, thermal movement, and air infiltration while maintaining that tight, flush look architects aim for. The aluminum frames are engineered with internal drainage, vapor seals, and expansion joints that keep water and temperature changes from creating problems down the line. They also factor in building sway. In a high-rise, wind loads can move the frame inches back and forth. Harmon's curtain walls are built to absorb and adjust without cracking glass or breaking seals. That's where performance meets flexibility, not in appearance, but in hidden function. Installation is efficient. Because panels are pre-glazed and pre-sealed, field labor drops and timelines shrink. It also means better quality control. Everything is assembled in a factory setting, then shipped ready to mount. Sugarcrete doesn't look like concrete, and that's exactly the point. At first glance, it feels more like compressed earth or fiberboard, but this block system has real structural bite, and it's grown, not mined. Made from sugarcane waste, Sugarcrete combines bagasse with mineral binders to create modular blocks. They're strong enough to form load-bearing walls and light enough to handle without machines. Each interlocking block weighs around 5 kilograms, far lighter than concrete or fired brick. That means faster stacking, less lifting, and no curing time. The shape is smart too. A jagged edge along one side allows each unit to slot into the next without mortar, reducing thermal bridging and cutting down on labor. Reinforcement can be added vertically through hollow cores, making it possible to scale up into larger buildings or add seismic resistance. But the real story is how it's made. Unlike concrete, there's no high-temperature kiln involved. The blocks are pressed, not fired, which slashes the energy footprint. The sugarcane pulp, a byproduct normally burned or discarded, becomes a resource instead of waste. This gives Sugarcrete a carbon footprint nearly 20 times lower than traditional building materials. Its thermal performance is another plus. The fibrous makeup insulates well, helping regulate indoor temperature and reduce energy use over time. You don't really notice cable railings until they're done right. RDI Cable Railing leans into that simplicity. It's all about clear views, clean lines, and tensioned cables that disappear into the background while holding everything in place. The system uses horizontal stainless steel cables stretched tightly between powder-coated aluminum and composite posts. Each cable runs through pre-drilled holes, and tension is applied using concealed fittings at the ends. That tension is key. It keeps the cables from sagging, and it makes the whole setup feel solid and secure. Posts come pre-engineered for top or side mounting, and they're spaced to keep cables from bowing. When pressure is applied, important not just for looks, but for code compliance. Each post has internal supports that handle the load, so there's no need for bulky corner assemblies. The result is a railing that feels open and finished at the same time. Installation is straightforward. The cable kits are pre-cut or customizable, and most components snap or screw into place without specialty tools. Once installed, there's little maintenance. The cables won't stretch much, and the materials resist weather, UV, and wear. That's part of the appeal after the install. You mostly forget about it. But it's not just about disappearing lines. It's about confidence. Lean on the rail, and it holds. Look through it, and the view stays sharp. On decks, stairs, or balconies, RDI system turns the edge of a space into a design feature without making it feel boxed in. Mbrico Tile Deck flips the script on outdoor flooring. Instead of wood planks or composite boards, it uses actual porcelain tiles IS, the same material trusted in kitchens and bathrooms, but engineered for patios, decks, and rooftop spaces. The result? A deck surface that doesn't warp, fade, splinter, or soak up water. At the core of the system is an interlocking aluminum rail structure. Tiles snap into place with hidden stainless steel clips, so there's no grout, no adhesives, and no screws through the surface. Each tile sits slightly above the frame, allowing water to drain through the gaps and air to circulate beneath. That airflow helps keep things dry underneath, while the porcelain top stays cool to the touch even in summer heat. Each tile is dense and non-porous, so it won't absorb water or stain. Freeze-thaw cycles? No problem. These tiles are rated for outdoor exposure and can take serious abuse. Heat, snow, UV, salt. They're also rated for slip resistance, making them a strong choice around pools or on elevated walkways. The panels come pre-assembled, meaning installers don't have to piece the system together on site. Snap them in, adjust the structure as needed, and the job's done. If a tile ever chips or cracks, pop it out and replace it, no tools, no downtime. It's a modular setup that looks like stone, but acts like a precision-fit system. Aesthetically, it's clean and crisp. Straight lines, tight seams, and finishes that range from wood look to concrete to stone. But it's the structure beneath that really matters. That frame is what separates this from glued-down tile, or floating paver sit, gives the deck its spine, and keeps everything aligned. Alva, or the White Tower, doesn't just rise, it redefines what a high-rise can be when concrete and computational design meet on new terms. Set in the Swiss Alps, it's the tallest 3D printed building in the world, standing at 29 meters tall. But its height isn't the headline. It's how the building came together that sets it apart. Each section of the tower was printed using robotic arms that layered fine concrete into curving textured walls. No flat panels, no molds, just code-driven motion and precision material placement. The walls are hollow but load-bearing, shaped with internal ribs that give structure without weight. These curves aren't just aesthetic, they control airflow, light diffusion, and even acoustic behavior inside. The outer shell is printed in segments, then stacked and secured on-site like architectural Lego. Every detail was digitally modeled. Where light should hit, how wind should move, where support was needed most. That tight feedback loop between software, material, and machines what made the form possible. The structure weighs less than traditional masonry and used fewer raw materials to achieve the same strength. What's inside matters too. Each floor plate was cast separately and dropped into the shell. Services were pre-routed, meaning wiring and plumbing slid right into position without last-minute drilling. Even insulation and finish layers were integrated into the wall design during the print phase. System 3 builds walls the way kids build, with blocks fast, clean, and without mortar. This construction system uses large, hollow ceramic blocks made from expanded perlite. They click together with precision-fit joints, forming structural walls without adhesives, cement, or even finishing layers. It's all about tight tolerances and a material that does more than one job. Each block is lightweight for its size, yet strong enough to bear loads in single and multi-story buildings. The perlite base gives it natural insulating properties, so walls don't need additional thermal layers. The blocks are also vapor permeable, helping regulate indoor humidity without trapping water inside the structure. The real game changer is the dry stacking. These blocks are machined to such precision that they fit together snugly without gaps. Workers simply stack them, level them, and keep building, no waiting for mortar to set, no mess, and almost no waste. Once up, the walls don't need plaster either. The surface is smooth enough to paint or apply final coatings directly. That speed has serious advantages. Crews can build entire home shells in days instead of weeks. No mixing, no downtime, and fewer tools needed on site. It's quieter too. Less noise, less dust, less disruption. The blocks are fire resistant, frost-proof, and dimensionally stable. They perform well in both hot and cold climates, and they don't shrink or swell with moisture changes. Because they're modular, they also make repairs or alterations easier down the line. Mapeguard system is the kind of protection you don't think about until water gets where it shouldn't. It's a waterproofing sheet membrane made for tile installations in wet areas, like showers, bathrooms, kitchens, or even steam rooms. But unlike messy liquid coatings, this system goes down clean, fast, and secure. The membrane is made from a multi-layered composite, a non-woven polyester fleece on both sides, and a polyethylene core in the center. That sandwich construction gives it strength, flexibility, and a reliable moisture barrier. It comes in rolls, is light to handle, and cuts easily with a utility knife. Once unrolled, it's applied directly to the substrate using a modified thin-set mortar. The fleece bonds tightly to the mortar, creating a strong mechanical grip. Seams are overlapped and sealed with Mapeguard WP adhesive or banding tape, making the whole surface watertight. Corners, edges, penetrations, and all. The real advantage? Speed and consistency. There's no waiting for curing or second coats. As soon as it's down and sealed, tiling can begin. That's a game changer for pros trying to shave hours or even days off a project timeline. Mapeguard WP isn't just for floors either. It's rated for walls, ceilings, benches, and any detail that needs waterproofing before tile goes on. Once installed, it stays hidden beneath the surface, doing its job quietly. It blocks water, controls vapor, and protects the structure below from slow, silent damage. No cracking, no peeling, and no surprises years down the line. Bison LevelUp deck are about getting flat, stable surfaces, no matter what the ground throws at you. Whether it's a rooftop, sloped concrete, or an uneven patio base, this system lets you install raised decking without digging, pouring, or leveling the surface underneath. The secret? Adjustable pedestals that lock in height with precision, creating a floating platform above whatever's below. Each pedestal adjusts from as low as 1/8 inch to over 36 inches tall, depending on the model. Twist the collar and the pedestal rises or lowers, holding its position without slipping. Integrated shims fine-tune the slope up to 1/2 2 inch per foot, so you can flatten out anything from a gentle tilt to a full drainage slope. The result is a level surface fast, repeatable, and tool-free. These pedestals support a range of surface materials: wood tiles, concrete pavers, stone slabs, or even composite decking. They create a clear space underneath for airflow, drainage, and electrical or plumbing lines. In commercial rooftop decks or high-end terraces, that hidden gap becomes a game changer. No water pooling, no trapped debris, and easy access to services if anything needs repair. Installation is simple. Lay out your grid, adjust the heights, and drop in the decking. There's no mortar, no adhesive, and no damage to the surface below. If the layout changes or tiles need replacing, just lift and swap. No demo, no drama. What makes Bison stand out is how it turns rough, irregular substrates into usable, elevated platforms, clean, level, and ready to finish. It's not just a support system, it's a fast track to usable space where nothing seemed buildable before. Some solutions are invisible by design. Cobiax SL is one of them. On the surface, it looks like a solid concrete slab. But inside, it's hollowed out with high-performance plastic voids that reduce weight without sacrificing strength. The real trick is that you never see it working, yet it reshapes how slabs behave from the inside out. Each slab includes a grid of hollow spheres made from recycled plastic. These are encased in steel cages and placed between two layers of rebar before the concrete is poured. The result? A two-way reinforced slab that uses up to 35% less concrete by volume while maintaining the same structural performance. That means fewer materials, lower dead loads, and longer spans with thinner slabs. Less weight on the structure opens the door to leaner columns, reduced foundation loads, and even fewer support walls, creating more open space for architects to play with. But Cobiax doesn't compromise on safety. It complies with Eurocode and other international standards for fire resistance, vibration control, and seismic behavior. It also plays well with standard construction practices. There's no need for special equipment or unique installation techniques. The cages are lightweight, easy to place, and come in several sizes to fit various slab thicknesses, from slim 20cm decks to 50cm structural floors. What you're really getting is efficiency hidden in plain sight. Every slab with Cobiax inside looks and feels just like a regular concrete floor, but it performs better. It's lighter, it spans farther, and it uses fewer raw materials, which makes it more sustainable without changing how crews build. You probably wouldn't think twice crossing one, but FRP bridges are quietly changing how small and mid-span bridges get built, and how long they last. Made from fiber-reinforced polymer, these structures ditch traditional steel and concrete in favor of materials that are strong, lightweight, and don't degrade the way metal or rebar does over time. The core of the system is a composite panel made from layers of fiberglass, carbon fiber, or other high-strength fibers embedded in a resin matrix. These panels are manufactured off-site, shipped in whole sections, and lifted into place with minimal foundation work. A full bridge can be installed in hours, not days, without heavy equipment or lane closures. Despite their weight, sometimes a fraction of what a steel deck would be, FRP bridges hold their own. They handle typical vehicle loads, pedestrian traffic, and even industrial use in some cases. But it's the long game where FRP shines. It doesn't rust, it doesn't spall. It doesn't need regular painting or patching. Maintenance cycles stretch way out, and that means lower total cost of ownership over decades. The surface can even be textured or layered with wear-resistant finishes for better traction and longevity. FRP also opens the door to creative design. Curves, colors, integrated lighting. These are easier to build into the form at the factory, not bolted on later. And because the bridge doesn't weigh much, foundations can be smaller and less invasive, which is key for protected or sensitive environments. And pneumatic vacuum elevators don't look or work like your standard lift. There's no bulky shaft, no cables, and no massive counterweights. Instead, they rise and fall using air pressure. That's right, Just physics, a sealed tube, and a clever use of vacuum. Picture a clear vertical cylinder, usually made from aluminum and polycarbonate. Inside it, a compact passenger cabin rests. When the elevator needs to go up, the system reduces air pressure above the cab. The higher pressure below gently pushes the cabin upward, floating it up the tube. To descend, air is released back in, and gravity takes over. It's smooth, quiet, and surprisingly gentle. These systems are self-supporting, meaning they don't need structural walls or pits. They sit directly on the existing floor, which makes installation fast sometimes within a few days and minimally invasive. That's a big deal in existing homes, where retrofitting traditional elevators would mean major construction. The cabins typically hold 1 to 3 people, with models rated for up to 525 pounds. Travel heights can reach 5 stops or about 50 feet, depending on the configuration. Doors are clear, the ride is panoramic, and the footprint is compact, usually under 4 feet in diameter. Energy use is another upside. The system only uses power when going up. Descent happens with zero energy, just a controlled release of air. And since there are no oils, lubricants, or cables, maintenance is minimal. These elevators are often installed in private homes, small offices, or unique spaces where traditional elevators can't go. Beyond the science, there's something elegant about it. No machine room, no steel cage, just you and the view, rising gently on a cushion of air. Mechanical concrete doesn't just fill potholes, it rethinks the road beneath your tires. Instead of relying on traditional aggregate or compacted soil for roadbeds, it uses a surprising upgrade: old tires. More specifically, it repurposes the sidewalls of steel-belted radial tires, turning them into confinement cylinders that hold crushed stone in place like never before. Here's how it works. The tread is removed from a tire, leaving a tough, circular ring of reinforced rubber. These open cylinders are placed in rows and filled with gravel or crushed stone. The result is a confined core that resists shifting, spreading, and settling. It's simple, scalable, and doesn't require special materials or heavy machinery to install. What makes it different is how the confinement works. When vehicles pass over traditional unbound stone, the load spreads, and the stone can push out or settle over time. But inside these tire rings, the stone is locked in place. It holds its shape under pressure, reduces deformation, and provides better load transfer with less long-term maintenance. Roads built with mechanical concrete have shown greater resistance to rutting and base failure, especially in areas with soft soils or heavy traffic. ThermaBead doesn't come in sheets or rolls, it flows. This cavity wall insulation system uses tiny expanded polystyrene beads injected into walls through small holes, filling every corner and gap with a consistent, high-performance thermal layer. It's fast, clean, and once in, it stays put locked in place by a bonding agent that keeps the beads from settling over time. The beads themselves are lightweight and round, about the size of a grain of rice. When pumped into the wall cavity under controlled pressure, they move around wiring, fixtures, and uneven surfaces, reaching places that traditional bats or boards can't. The adhesive sprayed alongside them creates a stable matrix that holds its shape without sagging or shifting even years later. ThermaBead systems typically achieve U values down to 0.27 watts per meter cubic, depending on wall type and depth. That's a serious thermal performance boost, especially in older homes or buildings with uninsulated cavities. And because the system is breathable, it allows vapor to escape without trapping damp, helping maintain healthier indoor air quality. ACETube doesn't fight water, it works with it. This geotextile tube system is built for big challenges like shoreline protection, land reclamation, sediment control, and flood defense. It's not a wall, a dam, or a pipe. It's a long fabric tube filled with pumped-in material, usually sand or dredged sediment, and once in place, it holds firm. The outer shell is made from high-strength woven geotextiles, engineered to resist tearing, UV exposure, and hydraulic pressure. These textiles aren't just sacks, they're structural. Once filled, the tube forms a massive barrier that acts like a gravity wall, with enough mass to stop waves, build new land, or stabilize soft ground. Filling happens through dedicated ports along the top. A dredge or pump mixes sand with water, sending it into the tube like slurry. As the water drains out through the permeable fabric, the solid particles remain, building a dense, stable core. The result is a long, solid structure that doesn't need concrete, rebar, or heavy equipment to install. Sizes vary, but some ACETube units stretch over 100 meters in length and reach several meters in diameter. They can be stacked, overlapped, or anchored depending on the project needs. In erosion zones, they absorb wave energy before it reaches the shore. In land reclamation, they create breakwaters or core barriers that support future fills. What makes them powerful is their flexibility both in shape and use. They conform to the ground they're placed on and can be installed in shallow water or soft soils where rigid systems fail. Ames Blue Max isn't just a coating, it's a waterproof barrier in a bucket. This thick, liquid rubber membrane is designed to seal foundations, walls, basements, roofs, and more from water intrusion. You brush it on, roll it, or spray it. And once it cures, it becomes a seamless, flexible shell that expands and contracts with the structure it's protecting. The formula is water-based and non-toxic, yet once it sets, it forms a rubber-like surface with up to 800% elongation. That stretch matters, especially in foundations or wall systems that move slightly over time. Where rigid membranes can crack or split under shifting loads, Blue Max flexes and keeps on sealing. It's applied in multiple coats, usually to a thickness of 30 to 40 mils. The first coat bonds into the surface, and the second fills gaps, bridges hairline cracks, and creates a watertight layer. It adheres to concrete, wood, metal, and even previously painted surfaces. Once cured, it resists mold, mildew, and standing water. Because it's a liquid, it conforms to complex shapes and penetrates surface irregularities. That makes it ideal for foundations with pipes, vents, corners, or other tricky areas. There are no seams, no overlaps, and no joints, just one continuous barrier that keeps water out. It can be used indoors or outdoors, above grade or below.